Welcome everyone. In this video, I will be solving questions, past paper questions regarding electrolysis chapter. The questions made from 2022 to 2020, and I included March papers and also summer and winter. All papers are included. Okay, 41, 42, and 43 as well. So let's get started with the first question. Yeah, a student carries out an electrolysis experiment using the apparatus shown. Okay, so we have carbon electrodes, and here we have dilute sodium chloride. Okay, NaCl aqueous. So guys, the ions found here are Na plus Cl minus, and we have H plus and OH minus as well, right? This is from water. State the name given to any solution which undergoes electrolysis. So this is this is simple definition of electrolyte. Okay, the definition of electrolyte. But let's move to the next question. They say that hydroxide ion are discharged at the anode. Okay, discharged at the anode. So as we said, we have Na plus and Cl minus. This is from NaCl. I think was NaCl, right? Dilute sodium chloride, yes. And we have H plus and OH minus. So they say that OH minus will be oxidized actually at the anode. Write the half equation. So guys, look, I suppose that you memorize this equation. This equation is the most important one. So I always ask my student to memorize it. So we have 4OH minus gives us 2H2O and the rest. Explain how the ionic half equation shows that the hydroxide ion are being oxidized. So how can we prove that this is oxidation reaction? So electrons are lost. Okay, so look guys, whenever you see electrons on the product side, so this is must be oxidation reaction. Okay, so here we have losing of electrons. And if the electrons were on the right, this will be reduction. Describe what the student observed at the cathode, at the positive electrode. So look guys, the electrolytic cell look like this. Yeah, so here we have, as we said, we have 4 ions, and here we have the positive electrode and the negative electrode. To the negative electrode, 2 ions will be attracted, but only one of them will be reduced. So in this scenario, H plus is the one that will be reduced. Okay, and the reason why is we depend on the reactivity series. We see that the sodium is the top of the reactivity series and H is on the bottom. So as you move down, the ions of the species will be more readily to be reduced. Okay, so we have, for example, potassium, sodium until we reach to the hydrogen. So if you have H plus, the ion of hydrogen, and for example, K plus or Na plus, these things will not be reduced. H plus is the one that will be reduced. Below the hydrogen, we have Ag, okay, and we have also copper. So if you have H plus and Ag plus, for example, Ag plus is the one that will be reduced, okay, because it's just below the hydrogen. So what student observe at cathode? At cathode, we will see fizzing because hydrogen is being liberated. Okay, H plus is being attracted to the cathode. Write half equation for the reaction at the cathode. We see that H plus accept electrons and become hydrogen. Now we have a problem with this, guys. The problem is hydrogen is diatomic. It cannot be write only H, so it must be H2. So we have 7 diatomics. I hope you know them. Hydrogen is one of them. And this one will be multiplied by 2 for balancing, and here we will have 2 electrons. And this is the answer for this equation. We move to the next one. The students repeat the experiment using concentrated aqueous sodium chloride. Describe what the student observed at. So look, guys, here we have once more, here we have the positive, and here we have the negative part. And we said we have concentrated aqueous sodium chloride. So we have Na plus Cl minus and OH minus and H plus. Look, guys, at cathode, yeah, so at cathode, now which substance will be attracted? Once more, at cathode, yes, aqueous sodium chloride. So at cathode, H plus will be attracted, it gains electrons, and it becomes hydrogen gas. Okay, here hydrogen gas being liberated. Hydrogen gas being liberated. So once more, guys, you will see fizzing. You will see fizzing. And talking about anode, guys, in case of anode, what are the species here attracted to the anode? Is it Cl minus or OH minus? And how do we know? So according to the question, they say that concentrated. So when you see this statement, when you see concentrated, that means the Cl minus is the one that will go to the anode. And guys, look, if you have OH minus and you have Cl minus or I minus or whatever from these halide ions, and the solution was dilute, then the OH minus will go to the cathode, sorry, to the anode. But if you have one of these concentrated solution, then these will go to the anode. So in this scenario, Cl minus is the one that will go to the anode, and Cl minus at anode will become Cl2, oxidized to Cl2. And we know that this one is a green gas. Okay, so green gas will be liberated. طيب, the student added litmus to the solution after electrolysis of concentrated aqueous sodium chloride. State the color seen in solution. Give the reason of your answer. So look, guys, after electrolysis, H plus ions will be removed, Cl ions as well will be removed. So the remaining is NaOH, NaOH. Okay, so the solution, the color of solution will be blue. Okay, because it is basic solution. It is basic solution. Now it is base. Okay, why? The reason, sodium hydroxide is made, NaOH is made because H plus and Cl minus ions are removed. Carbon electrodes, so next question. Carbon electrodes are used because they are inert. Okay. State another element that can be used instead of carbon. So guys, we always use either carbon or platinum. Okay, we use carbon or platinum. So this is the first part of today's questions. This is from, I think, 2020. Yeah, 2022, sorry. Moving to the next question, let me make the screen bigger. Zooming. So let's see the question. Yes. Wait, just give me 1 second. طيب. aqueous sodium fluoride. Aqueous sodium fluoride. Okay. So NaF aqueous undergoes electrolysis. So what do you mean by electrolysis? This is very important, guys. How do we define electrolysis? So electrolysis simply it is the breakdown of molten or aqueous ionic compounds of aqueous ionic compound by the passage PASSAGE of electricity. So this is, guys, as I told you, this is very important. The definition of electrolysis and the definition of electrolyte, as we will see in the next questions. Name the products formed are the positive electrode anode and the negative electrode cathode when dilute aqueous sodium fluoride undergoes electrolysis. Sorry for this. Let's continue. Guys, sodium fluoride is NaF, as we said, and they say this is dilute. So guys, here we have two ions. We have Na plus F minus from sodium fluoride. We have H plus OH minus from the water. And here we have our Cl. Okay, so suppose that this is anode, and let's say that this is the cathode. Okay. As we know that one of these positive ions will be attracted toward the cathode, but one of them will be reduced. So which one? As I explained in the previous question, H plus is the one that will be reduced. So H plus electron give us H2 for balancing 2H plus 2 electrons. So the substance that will be produced at cathode is hydrogen. And talking about the anode, F minus and OH minus, both of them will be attracted to the anode. One of them will be reduced. As long as the solution is dilute, as it is written here, dilute here. So OH minus is the one that will be oxidized. So we know that 4OH minus gives us 4 electrons plus 2H2O plus oxygen gas. So we will see that oxygen here will be made. That's it. Molten sodium fluoride. Now, guys, we turn to another thing. We turn to molten. Molten mean we have only Na plus F minus. There is no H plus and OH minus anymore. Name the products formed at the positive electrode and the negative electrode. So let's see what will happen. For the negative electrode, sorry, for the anode, F minus will be attracted. So on the anode, F minus will be F2, right? This is oxidized to F2. So we will see fluorine. And for the cathode, sodium will be reduced. So we say sodium. That's it, we're done. Write the ionic half equation for the reaction at the negative electrode. Guys, at the negative electrode, we say sodium ions goes there. So Na plus 1 electron give us Na. That's it. So this equation now is over. Let's move to the next question. Stop the video, have a look, and let's solve it together. It states the meaning of electrolyte. So what do you mean by electrolyte? So guys, electrolyte, it is molten or aqueous, aqueous, ionic compound that is, or that yeah, that is undergoes electrolysis. Okay, so that undergoes electrolysis. Yani, is the compound that we break it down. For example, if we have NaCl, if we have molten NaCl, here we have a negative, Na plus Cl minus. So NaCl by electricity, or this compound, the ionic compound NaCl, by using electricity, it will be broken down to sodium metal and Cl2 gas. So yeah, this definition required. So next question, the table gives information about the electrolysis of two electrolytes. Carbon graphite electrodes are used by inert electrodes. Complete the table of observation and the products of electrolysis. So here, guys, we have copper sulfate, CuSO4. Okay, here we have CuSO4. So at the positive electrode, at the anode, we see colorless bubbles. Look, guys, for CuSO4. Here we have cathode, and here we have anode. CuSO4 aqueous. That means we have Cu plus 2, SO4 minus 2. We have H plus and OH minus from water. To the anode, these, sorry. Yeah, wait. Yes, to the anode, these two negative things will be attracted there. OH minus and SO4 minus 2. So which one of them will be oxidized? It is always OH minus. Look, whenever we have OH minus and SO4 minus 2, always OH minus will be oxidized. So we know 4OH minus will give us oxygen. This is the colorless bubbles. Name of the product is oxygen. Observation on the negative electrode, on the cathode. On the cathode, these two ions will go there. You must memorize the reactivity series, and if you memorize it, you will know that hydrogen, just beneath the hydrogen, we have copper. So copper is less reactive than hydrogen. That's why the ions of copper here, ones that will go to the cathode. So what will be observed here? You will observe a brown, BROWN, brown solid. And the name of the product is copper, guys, copper. But we have another thing here. Concentrated sodium bromide. Guys, it is NaBr, AQ. So we have Na plus Br minus, we have OH minus and H plus. Right. quickly. Which one of these will be attracted to the anode? To the anode, OH minus and Br minus are attracted there, right? But one of them will be reduced, sorry, oxidized, only one of them. Guys, the solution is concentrated. So it is the Br minus is the one that will be oxidized, right? Because it is concentrated. So you're gonna see an observation orange liquid will be made here. Br2, Br minus will be oxidized to Br2. 2 Br minus give us 2 electrons plus Br2. It's like this. Br2 is orange. Yeah, what it is a bromine. And here H plus will go to the, wait, sorry. These things go to the anode, not cathode. So sorry. Go to the anode. H plus is the one that will go to the cathode. That's it. We're done with this part of the question. We move on to the next part. طيب. Hydrogen is produced at the negative electrode during the electrolysis of concentrated sodium bromide. Hydrogen is produced. Hydrogen is H2. Right, ionic half equation. So it is 2H plus 2 electrons give us H2. That's it. طيب. State 2 reasons why carbon is suitable to use as electrode. So guys, it is inert and also it conducts electricity. But ask yourself, why carbon conduct electricity? Okay, because this is an important question. Think about it. طيب, another set of questions we're gonna see now. Aluminium is extracted from its ore by electrolysis. Name the ore of aluminium. طيب, so I suppose all of you know it is BAUXIT, bauxite. State what is meant by term electrolysis. We defined the electrolysis in the previous questions. Yeah, so let's move to the next one. طيب. Electrolysis is carried out on aluminium oxide dissolved in molten cryolite. طيب. Okay, so here we have the place where we perform the electrolysis process. Give 2 reasons why the electrolysis is carried out on aluminium oxide. Okay, why cryolite? Why electrolysis is carried out on aluminium oxide dissolved in molten cryolite instead of electrolyzing molten aluminium oxide only. So why do we add cryolite? Why do we add cryolite? So guys, you know that the process of electrolysis must be performed when Al2O3 is molten. So to melt this one, we need very high temperatures, but by adding cryolite, we decrease the temperature required. So we can say lower temperature required to melt aluminium oxide. And the second reason, guys, is to improve the conductivity of the electrolyte. Yeah, that's it. طيب. Next question. Write the ionic half equation for the reacting occurring at the negative electrode. So what will happen at negative electrode? Guys, we have Al2O3. When you melt them, it becomes Al plus 3 and O minus 2. At negative electrode or cathode, Al plus 3 will be attracted. So Al plus 3 plus 3 electrons, it will give me Al. That's it. طيب. Next question. طيب. Yes. A positive electrode is made out of carbon. Explain why the positive electrodes are replaced regularly. Why it is replaced regularly. So look, guys, in this case, we are producing, along with Al plus 3, we have O minus 2. O minus 2 will be attracted to the positive electrode here, to the carbon. O minus 2, guys, will become oxygen plus 4 electrons. This oxygen under the operating temperature will react with carbon to produce CO2. So the electrode or the positive anode will be eaten. Okay, so it must be replaced regularly. Let's move to the next set of questions, which is the last one for today's video. Okay, look, guys. The question is about electrolysis. Concentrated hydrochloric acid is electrolyzed using the apparatus shown. Just let me make this one bigger. Okay, now it's great. We have here the wire by which electrons are moving. We have carbon electrodes, and here we have HCl. Chlorine ions are discharged at the anode here. Chloride ions, sorry. Complete the ionic half equation for this reaction. So guys, we have 2Cl minus give us Cl2 plus 2 electrons. Okay, diatomic. This is diatomic gas. It must be Cl2. State whether the oxidation or reduction takes place. Guys, as I told you, when you see the electrons on the right side, so this is oxidation, okay? When you see the electrons on the product, so the process will be oxidation because electrons are lost, okay? Right. Oh, wait. To the next question. Describe what is seen at cathode. What is seen at cathode? At cathode. So here we have HCl, which is H plus Cl minus, and H plus OH minus from water, and this is from HCl. The question said, what will be observed at cathode? So guys, H plus, here we have only one positive ion. It is only H plus. Okay, so H plus will go there, will be reduced. So we're gonna see colorless gas being made. Okay, or we can say we see fizzing. This is the hydrogen gas. The next question, yeah, the reaction takes place here. So we know that this hydrogen to H plus plus 2 electrons, this will be H2. The pH of the electrolyte is measured throughout the experiment. We keep measuring the pH. Suggest the pH of the electrolyte at the beginning of the experiment. At the beginning, look guys, in here now we have HCl. HCl is a strong acid. That's why guys the pH must be 1. Okay, it is a strong acid, so the pH will be 1. So it is 1. Okay. Yeah, where it is, yeah, 1, as it is strong acid. State how the pH changes, if at all, during the experiment. Explain your answer. Look guys, as I told you, what is happening here, that H plus ions, as I told you, we have H plus Cl minus from HCl and H plus OH minus from water. H plus ions are attracted to the cathode and they become H2 gas. So H plus ions decreases, right? And the things responsible for making solution acidic is H plus, are H plus ions. These ions are responsible for making the solution acidic. And as long as these ions are being removed, so the pH increases, okay? The pH of the solution increases because H plus ions are lost or are being removed. That's it. The next question. Electrolysis is repeated using molten lead bromide. Molten. Molten, guys, means we have yeah, without water. So lead bromide, it is PbBr, right? Br2, molten lead bromide. طيب. Pb, guys, just 1 second. Yeah, Pb here is a +2 and Br here is minus. So Pb will be attracted to the cathode where it gains 2 electrons and give me Pb. So what's seen here on the cathode, we're gonna see a gray solid. Simply, we're gonna see gray solid. This is the GREY. This is the lead. On anode, guys, we know that the Br2 has orange color. Here we're gonna see orange color on anode. Because Br minus, it will be Br2. Br2 will be seen on the anode. State 2 properties of graphite making it. We solve such a question before. We say it is inert and conduct electricity. That's it. We're done, guys, with today's questions. And the next video will solve more questions.